For, well, basically all of human history, we've looked up at the night sky and just tried to figure it all out. Today, we're going to unravel one of the greatest astronomical puzzles of all time. It's a mystery that completely flipped our understanding of the universe and, our place in it. Okay, so let's dive right into the heart of the problem. The big question that had the smartest people stumped for centuries. You see, while the stars move in this nice, predictable arc across the sky, a few of those bright lights, the planets, would do something really weird. They'd slow down, stop, and then actually move backward for a bit before going forward again. What on earth was going on? And here, you can see exactly what they were dealing with. Against that fixed background of distant stars, a planet would trace this bizarre little loop-de-loop. Now, this wasn't just some minor little quirk. It was a fundamental puzzle about how the entire cosmos was put together. So our story really kicks off right here with this incredible puzzle of the wandering stars. And you have to understand, trying to solve this wasn't just for fun. If you couldn't explain this strange motion, it meant your whole model of the universe was just wrong. It flew in the face of this deeply held belief that the heavens were supposed to be perfect and predictable. So let's look at the first major attempt to explain it. And honestly, when you think about it, based on what you can see and feel every single day, this was a super intelligent and totally logical explanation. They called it the geocentric model. And look, it makes perfect sense, right? It doesn't feel like we're moving. It feels like we're standing still, and everything up there, the sun, the moon, all the stars, they all seem to circle around us. So, of course, the logical thing to do was to put Earth right at the very center of it all. But that still didn't explain why the planets moved backward. So, to make the math work, they came up with this really ingenious, if a little complicated, idea, the epicycle. And this shows you just how clever it was. Just imagine a planet is moving on a small spinning wheel, and that little wheel is attached to a much bigger wheel that's turning around the Earth. A circle on a circle. And you know what? This setup could perfectly recreate that weird, looping, backward motion they were seeing in the night sky. So what's the problem? Well, to get it just right, to match the real paths of all the planets perfectly, they had to keep adding more and more epicycles. We're talking circles on top of other circles. The whole model just got incredibly complicated and clunky. It worked, sure, but it was a real mess. And then along came a completely revolutionary idea, a total paradigm shift, thanks to Copernicus, that offered up a much more elegant and much simpler truth. Let's just put them side by side. The heliocentric model yanks the Earth out of the center and puts the sun there instead. And boom, all of a sudden, you don't need all those complicated epicycles anymore. Earth just becomes another planet, going around the sun like all the others, and the whole system gets way, way simpler. And here it is. This is the big aha moment. It turns out that retrograde motion isn't even real. It's just an illusion, a trick of perspective. Okay, think about it like this. You're in a car on the highway and you pass a slower car. For just a second, from your point of view, that other car looks like it's moving backward, right? It's the exact same thing. As our faster-moving Earth laps a slower-moving outer planet like Mars, that planet just appears to trace a loop in our sky. Mind-blowing, right? So, solving that ancient puzzle put the sun where it belongs, right at the center of our solar system. And that didn't just fix a math problem. It made us see our star in a totally new way. So, let's get to know the real star of the show, the gravitational anchor that holds this whole amazing system together. And what an anchor it is. Just let this number sink in for a second. The sun makes up 99.9% of all the mass in our entire solar system. Everything else, all the planets, including Earth, all the moons, asteroids, comets, the whole shebang is just a tiny bit of leftover dust. Now, like all stars, our sun has a life story. It was born, it's living, and one day it'll die. At about 4.5 billion years old, our sun is comfortably middle-aged. It's in the most stable, calm phase of its life, and it's got billions of years to go before it swells up into a red giant, and then eventually fades away into a white dwarf. And just to give you a sense of the sheer power we're talking about, here are the vital stats. The sun is this giant ball of superheated gas called plasma. It's so hot, the atoms are literally torn apart. The temperatures are just insane. 15 million Kelvin at its core, where all the action is, and it's still a blistering 5,700 Kelvin on its visible surface. So what's actually going on under the hood? What makes this thing work? To get that, we need to take a look at its anatomy, starting from the very center and working our way out. You can basically think of the sun as being made up of layers, kind of like a giant onion. We'll start with the deep internal layers where all the energy gets made, and then we'll move out to the atmosphere, the parts we can actually see. Okay, so it all begins deep down in the core. The pressure and temperature there are so intense that hydrogen atoms are smashed together to create helium. That process, nuclear fusion, unleashes an unbelievable amount of energy. And then that energy starts this incredibly long journey outward, first slowly pushing its way through the super dense radiative zone for maybe thousands of years. Once the energy finally makes it to the outer layers, we get to the parts we're more familiar with. The photosphere is that bright surface we actually see. Above that, you've got the chromosphere, and then this incredibly hot, wispy outer atmosphere called the corona. And here's a weird mystery. The corona is millions of degrees hotter than the surface below it. We're still trying to figure that one out. But the sun isn't just some far-off, perfectly calm ball of fire. No way. It's a dynamic, active, and sometimes violent star, and we are living with its mood swings every single day. This image always gets me. It gives you an incredible sense of scale. You see those dark patches? Those are sunspots, cooler spots caused by intense magnetic fields. And that tiny little black dot? Yeah, that's our entire planet, Earth. It's just a humbling reminder of how absolutely massive our star really is. And the sun's activity isn't random at all. It actually follows this pretty predictable 11-year cycle. The number of sunspots, solar flares, and big eruptions ramps up to a maximum and then fades down to a minimum. This cycle is the main engine behind what we call space weather, which can mess with our satellites and even power grids right here on Earth. And that really brings us to our final thought. We live our lives next to this enormous nuclear furnace in the sky. It's the star that gives us life, but it also has the raw power to unleash these incredible storms of energy our way. Which leaves us with a pretty provocative question to chew on. Just how vulnerable are we, really, to the moods of our nearest star?